Greetings, esteemed judges and respected viewers. We live in an era defined by grand challenges, from energy transitions to resource scarcity. The world is grappling with problems that often feel too large for any one individual to solve. However, as students and observers of the world around us ourselves, we believe that the best solutions aren't always found in complex new inventions, but in the intelligent redesign of the waste we already create. Today, we are here to present a vision, one that takes a neglected byproduct of our modern comfort and turns it into a catalyst for life. We are Team DewPoint.
I am Raghav, the lead designer. My focus has been on the structural integrity and the fluid dynamics of our contraption, ensuring that our vision can be manufactured and integrated seamlessly into existing infrastructure.
I am Reagan, the presentation curator. I'm responsible for the narrative of our innovation, bridging the gap between technical engineering and the environmental impact that we aim to achieve.
And I am Ibrahim, the lead data analyst. While my teammates focus on the physical and the narrative, my role is to ensure that the core logic behind our innovation remains bulletproof. I oversee the systemic architecture and the high level data modeling that validates the feasibility of our project.
Now, let's look at the reality of our environment. In the UAE, air conditioning is not a luxury, it's a lifeline that comes with a hidden heavy cost. Every hour, millions of units are mining water from the humidity in our air. This water is currently treated as a liability. It is dumped into our sewage systems at a rate of billions of liters per year. But it is not just a waste of volume, it's a chemical failure. This condensate is dead water. It's acidic, mineral deficient, and very aggressive. It corrodes building pipes and, if used for greenery, will starve the soil. We are effectively paying to desalinate the water with massive energy footprints while simultaneously throwing away a pure pre cooled resource that is dripping off our buildings. This is the invisible crisis of the desert. We are drowning in a waste stream that we should be drinking from.
To solve this, we developed DewPoint. Structurally, it is a 44 cm vertical cylinder with a 16 cm diameter, designed to clip directly onto standard AC drain lines. It consists of a high density UV resistant outer casting of high density polyethylene divided into three distinct functional segments. We chose these dimensions to ensure the unit remains compact enough for a balcony but large enough to handle the peak flow rates of a high pressure cooling system without causing back pressure. It's a passive, gravity fed system. No power, no pumps, just physics.
Now, let's look at the fine details of dew point. The first segment, Zone A, is our velocity drop sediment trap. Water enters from a narrow pipe and expands into this wider chamber. According to basic fluid dynamics, this expansion causes the water's velocity to drop instantly. This is crucial because AC condensate often carries bioslime and dust from the cooling coils. By slowing the water down, we allow these heavy particles to settle at the bottom of the chamber and undergo filtration through the plastic grid, catching larger particles, and the 150 micron stainless steel mesh capturing smaller particles. This ensures that the primary mineral bed in the next stage remains clean and unfouled, which not only drastically extends the life of the cartridge but also ensures that only the best quality of water is being mineralized.
Zone B is the heart of innovation. Here, we utilize a 2:1 ratio of dolomite to calcite pellets with additions of gypsum. But the secret is the arrangement. We have engineered what we like to call the serpentine path. Instead of the water falling straight through, a series of staggered perforated plates force the water to zigzag. This effectively triples the contact time within the same 44 centimeter frame. This prolonged exposure is what allows the water to actually absorb the minerals. The acidity is neutralized as the pH rises to a stable 7 and the water becomes enriched with the calcium and magnesium necessary for plant cell wall strength.
Finally, the water enters Zone C. This is our safety stage. It contains a high porosity activated carbon paper. This removes any metallic or musty odors common in AC runoff. More importantly, it acts as a final filter for any microscopic organic matter. This ensures that the water exiting the dew point unit is not only chemically balanced but biologically safe for residential gardens and public spaces, meeting the high standards for unrestricted irrigation.
The time has now come to look at the numbers and the scale of the impact of our innovation. After referring to various housing reports posted by official government agencies, we perform the following calculations. Our data modeling uses the UAE's 10.3 million tons of residential cooling capacity as a baseline. In the peak of summer, our system identifies a recovery potential of 201.8 million liters per day. To put that into comparison, that is 27 Olympic sized swimming pools, 7 Eiffel Towers, and even 2 Statues of Liberty. As you can see on the graph, our production curve perfectly aligns with the UAE's peak irrigation demand during the summer. Even when we apply a conservative real world factor to account for winter months and travel seasons, the net annual yield is 20.24 billion liters. Across the nation, we are looking at a recovered value of over 1.4 billion dirhams, which would have been used to desalinate this amount of water. These aren't just drops in a bucket, this is a new national reservoir in the palm of our hands.
Viewers, the UAE has always been a nation that turns the impossible into the inevitable. We were told that the desert couldn't be green, yet we build a garden in the sand. With DewPoint, we are simply just finishing the job. We are taking the water that the sky has already given us and giving it back to the earth. We don't need to find any more water. We just need to stop throwing it away. After all, we are Team DewPoint. Thank you.